Hello, beautiful internet people. Today I want to talk a little bit about how ChatGPT actually works, how it was built. But, for people that aren't really looking to be like AI research scientists or something, but maybe just want to impress their friends at the next staff meeting, party, virtual non-existent water cooler gathering thing. If we play buzzword bingo here, there's a beastly combination of things that are building up to be ChatGPT. There is deep learning, reinforcement learning, transformers, text and code embeddings, humans in the loop, and few-shot learnings. Lots and lots and lots of concepts that, even go around those. But we can't cover all of that in a short video, and we probably couldn't even cover that in a long video. It'd be like 4 days long. Before we even get to ChatGPT, there's the base model GPT-3 and the sibling models InstructGPT and Codex. InstructGPT can basically be thought of as baby ChatGPT, and Codex can be thought of as coding ChatGPT. It's the first one to do the programming side of the things. Okay, so the two biggest things that jumped out to me from the hundreds of pages of papers that I read, so you don't have to, are the few-shot learning used in the original GPT-3 base model 2 years ago, and the human-in-the-loop methodologies used in the InstructGPT that were also then applied to ChatGPT. The core base model, GPT-3, builds on the idea of transformers. Not the ones from your childhood that turn into semi-trucks, but models that maintain awareness of the inputs and the outputs and the sequence at a greater depth than previous models. What was super cool in GPT-3 was it brought it to just a ridiculously massive scale. It had 96 layers of alternating sparse and dense layers that used 175 billion parameters that were trained with 300 billion tokens. But all of those numbers can just kind of be a lot of gobbledygook that you might not care about. The easiest way to think about how this model works, though, is to know that it's an evolution of text completion, something that we've been seeing in our phones, our Word documents, and pretty much ubiquitous in our life for, like 10 years now. All of those earlier text completion models were based on some form of machine learning. And as we have continued to grow the size and the complexity and the methodologies that we use this, we have also been growing the amount of data that's available. Every time that you click yes or you click autocomplete or whatever, that's being registered as, okay, this is the right sequence of words to follow these previous words. So if we carry the idea of text completion, word completion, forward, word after word after word, we get full sentences. However, if you've ever played the game on your phone where you just keep clicking the middle word over and over and over, you get a rambling bit of nonsense. So to move past that rambling bit of nonsense, you need a model that understands more of the sentence and more how that sentence fits into the context of whatever task is trying to be completed. So to create a model that understands more of these sorts of, what's the context of the sentence, what are the entities and intents in the conversation and the body of content, you need something like a transformer. The transformers remember what was put into it, what the request was, and they're going to remember much more about what the sentence is, back to even hundreds or thousands of words earlier. So let's take an example sentence of, I'm having coffee with a sassy elf like. Let's say that's our prompt. An older model would probably spit out ears, because elf-like has the highest probability of being followed by ears, elf-like ears. But a transformer would look at the broader context and see that it's, talking about having coffee and that the elf is a person and that there's a different intent here, and we're not talking about ears in any way. Clever transformer might complete the sentence, so I'm having coffee with a sassy elf like, we're never going to run out of syrup. Who knows? In addition to transformers, GPT-3 used an idea of few-shot learning, where in addition to the prompt, the model would be provided a couple of example outputs of, hey, this is what you should be producing, but it wouldn't necessarily do a feedback loop into the base model to update the weights and parameters and things like that on top of the initial training. This created a fine-tuning layer on top of the text completion model that could do more specific tasks like write poetry, create recipes, eventually write code, and do some of the things that we're starting to see now in ChatGPT. If we're thinking about this few-shot learning, and we want to think of it as an example, what would happen is we would provide an input to the model, a prompt to the model with something like, tell me about cheesecakes. And then we would also provide, say, 3 target output responses, like cheesecakes are made with milk, cheesecakes are sold at the Cheesecake Factory, cheesecakes go good with chocolate. And then the model would produce something like cheesecakes give me gas. And then, but the error correction around that would not be passed to the base model. It would only be used in the fine-tuning layer. So once you had a model that can understand the qualitative complexities of sentences and paragraphs, you then need to teach the model which sentences and paragraphs are more useful. Like, cheesecake gives me gas may not be the most useful thing, as cheesecake is very tasty and yummy and a great dessert, right? There's qualitatively different objective rankings in the sentences. So to do this fine tuning layer of what's not just a grammatically correct response, but what's a high quality response, OpenAI used a human in the loop approach, and they outlined this in the Instruct GPT paper. So for the Instruct GPT model, which was a precursor to ChatGPT, they call it a sibling model, this human in the loop method was used. The way that this was done is a human, still human, would input a prompt of, tell me about cheesecake, and then they would also provide their answers. The model would spit out its answer. The human responses were combined with the AI generated responses, and then the ranking of where the AI response fell within the overall rank provided a reward back into the reinforcement learning model that was used on top of the fine-tuning layer. The easiest way to think about this is the model was given a treat, like when you tell your dog to sit and they plop right down, you give them a treat. They did that with the model, so the model knew what good behavior, what good quality was. This human in the loop process then produces the ChatGPT that's now in public release and being further trained by all of us humans who are giving it more prompts and giving it thumbs up, thumbs down, and in some cases, if we're really helpful people, we're writing what we think the response should have been. To give you an idea of how ChatGPT is aware of context, let's have it generate a top 10 list of how a red shirt might die and put its pop culture knowledge to the test. Okay, so if we ask ChatGPT to tell us how red shirts will perish in Star Trek, we can see it starts to do this. The key thing that I want to point out to you guys is notice it's doing this one word at a time. You can even see it pause here and there. The other thing that I'd like to point out, though, is notice it says things like crashing on unknown planets or moons. It's actually enhancing the context of that. And then the absolutely most clever thing about this is I love it tells us, hey, just so you know, this is a fictional thing. For all of you sassy, unserious elves out there, I have linked the blogs, apps, research papers, everything that I read and used to summarize all of this up in as quick of kind of thing as possible. And if you're feeling even more unserious, be unserious with us and watch some more videos.